Rolls-Royce has ruled the skies for over 100 years, but that century-long reign is now being threatened by a single number, 35,000 kilograms of thrust. Almost everyone in the aviation world assumed China would need decades to even get close to Western engine technology. But the CJ2000 engine has blown past every single one of those expectations. Beijing isn't just trying to catch up anymore. They're building something designed to flip the entire industry upside down. So how exactly does this engine plan to outsmart the best that the West has ever built? And why is this one program sending shockwaves through boardrooms from Derby to Seattle? Before we get into it, if you haven't already, take a second to subscribe. It genuinely helps this channel keep digging into stories like this one. Now let's get into it. Let's start with the how, because that's really the heart of this whole story. How does a country that was building basic turboprops just a couple of decades ago suddenly plan to outsmart 100 years of British engineering excellence? It's not simply about building something bigger, it's about building something smarter, lighter, and more efficient at the same time. And the numbers coming out of Chinese testing facilities right now are honestly unsettling if you're sitting in a boardroom in the West. For years, the Rolls-Royce Trent XWB has sat comfortably at the top of the wide-body engine world, producing somewhere between 84,000 and 97,000 pounds of thrust, depending on the variant. It's an extraordinary piece of engineering, refined over generations, trusted by airlines across the globe. But China's answer to it, the CJ2000, isn't just trying to match that number, it's aiming to blow straight past it. Recent ground tests out of China have reportedly shown the engine prototype hitting roughly 35,000 kilograms of force, which works out to around 77,000 pounds of thrust in what's still considered an early testing phase, with a stated roadmap to eventually scale that figure up beyond 100,000 pounds of thrust. That number puts the CJ2000 squarely in the heavyweight category, easily capable of powering something the size of the C929 widebody without breaking a sweat. But raw thrust is really only half of this story, and honestly, it might not even be the more important half. China is going after something much more fundamental, the actual materials the engine is built from, using what's called ceramic matrix composites, or CMCs for short. Traditional jet engines, including the ones built by Rolls-Royce and GE, rely heavily on nickel-based superalloys in their hottest sections. Materials that are strong, but also heavy, and limited in how much heat they can tolerate before they start to degrade. The CJ2000, on the other hand, uses these advanced ceramic composites specifically in the high-pressure turbine section, which is the single hottest and most punishing part of any jet engine. Why does that material choice actually matter so much? Because ceramic matrix composites can operate at temperatures somewhere between 200 and 300 degrees Celsius hotter than traditional metal alloys, all while weighing roughly a third as much. Think about what that actually means in practice. A component that can survive hotter conditions allows engineers to run the whole engine core at a higher temperature, and in thermodynamics, hotter generally means more efficient. Combine that heat tolerance with a new generation of lightweight carbon fiber fan blades up front, and you end up with something remarkable. A reported 15% boost in fuel efficiency compared to the previous generation of engines. In an industry where a single percentage point of fuel savings is treated like a massive breakthrough worth celebrating for years, a 15% jump isn't just impressive, it's close to revolutionary. Try to imagine the mood inside the engineering offices in Derby, England right now, where Rolls-Royce has spent decades perfecting titanium alloys and painstakingly refining every last percentage point of efficiency out of traditional materials. Now they're watching a competitor potentially leapfrog generations of that work using ceramic composites and three-dimensional printed components that cut weight dramatically while maximizing how efficiently heat moves through the engine. It's the kind of technological shortcut that, if it holds up in real-world service, could make decades of incremental Western progress look almost quaint by comparison. But here's where this story stops being purely about engineering and turns into something closer to a masterclass in business strategy. Rolls-Royce has built its entire commercial model around something called total care servicing, an arrangement where airlines essentially pay Rolls-Royce for guaranteed engine performance and maintenance over the life of the contract. It's a brilliant business model from Rolls-Royce's perspective, incredibly profitable and sticky. But for airlines, it can feel like a golden cage, locking them into extremely high fixed costs for years or even decades at a time, with very little flexibility to shop around. China appears to be flipping that entire script. Instead of locking airlines into an exclusive closed maintenance relationship, the plan is reportedly to offer a much more open maintenance ecosystem around the CJ2000. In a post-pandemic industry where airlines are still desperately hunting for every possible way to cut costs, offering a high-tech engine with maintenance expenses projected to run somewhere between 20 and 25% lower than Western equivalents is an extremely compelling pitch. This is China hitting Rolls-Royce exactly where it hurts most, not on the tarmac, but on the balance sheet. It's a cold, calculated, deliberate strategy. They're not just trying to compete on raw power anymore. They're competing on the actual financial survival of the airlines themselves. Think about what this shift actually looks like from inside an airline's finance department. A total care service contract with a legacy manufacturer often means paying a fixed rate per flight hour that covers scheduled maintenance, unscheduled repairs, and parts replacement over the entire life of the engine, sometimes stretching across a 15 or 20-year contract. It's predictable, which airlines genuinely value, but it also means the manufacturer captures an enormous share of the long-term profit from every single engine sold, often far exceeding the profit made on the initial hardware sale itself. That's exactly why Rolls-Royce and its competitors have leaned so heavily into these service agreements over the past few decades. The real money isn't in selling the engine, it's in servicing it for the next 2 decades. If China genuinely undercuts that model with a more open, competitive maintenance ecosystem, it doesn't just threaten a single sale, it threatens the entire long-term revenue architecture that Western engine makers have built their businesses around. And that raises an uncomfortable question for the legacy manufacturers. Is a prestigious, century-old brand name really enough to keep airlines loyal when there's a genuine 15% fuel saving sitting on the table, paired with a dramatically smaller long-term maintenance bill? For airlines operating on razor-thin margins, brand loyalty tends to matter a lot less than the numbers on a spreadsheet. The technical gap between China and the West is closing faster than almost anyone in the industry predicted just a few years ago. But even with all of this impressive engineering progress, there are still some genuinely surprising twists buried in the supply chain story here. Twists that caught much of the global aviation community completely off guard. For years, the international community watched the CR929 program unfold as a joint venture, a marriage of convenience between China and Russia. The idea was straightforward on paper: combine Chinese manufacturing scale and capital with Russian aerospace engineering experience to build a genuine third option that could finally challenge the Boeing and Airbus duopoly together as a team. But then something nobody quite expected happened, what you might call an industrial divorce. China ultimately concluded that if they truly wanted to own their own future in the skies, rather than simply share ownership of a joint program, they needed to go it alone. By quietly stepping away from the Russian partnership and pivoting to an entirely Chinese-designed and Chinese-built C929, Beijing effectively hit the panic button on its own timeline. Suddenly, this wasn't just about building an airplane anymore. It became a frantic, high-pressure race to build the aircraft's heart from scratch, the CJ2000 engine. Why the sudden urgency? Because without a working, reliable engine of their own, the C929 is essentially just an extremely expensive metal glider sitting on a runway somewhere. In the high-stakes economics of commercial aviation, the engine alone represents somewhere between 25 and 30% of an entire aircraft's total value. Sit with that number for a second. Every single time a Chinese airline buys a Western-built engine instead of a domestic one, billions of dollars flow directly out of the country and straight into the pockets of Rolls-Royce or GE Aerospace. We're talking about an enormous, sustained wealth transfer that Beijing has apparently decided it is no longer willing to keep tolerating. There's also a quieter part of this story that doesn't get talked about nearly as much: the sheer speed of the pivot itself. Walking away from a joint program with an established aerospace partner like Russia isn't a decision any country makes lightly, especially when that partner brings decades of Soviet-era engine design heritage to the table. Russian engineers had experience building large, powerful engines for military and civilian applications going back generations. And losing access to that knowledge base overnight should, in theory, have set China's wide-body ambitions back by years. Instead, Beijing appears to have treated the split as an accelerant rather than a setback, funneling state resources, university research programs, and an entire generation of newly trained propulsion engineers directly into the CJ2000 program almost immediately. It's the kind of aggressive resource reallocation that's much easier to describe in a sentence than it is to actually execute. And the fact that testing milestones are already being hit years ahead of the original conservative timelines says a great deal about how seriously this program is being treated at the highest levels of government. You can practically feel the tension inside the engineering bays scattered across Shanghai right now. The people working on this program understand, at a deep level, that mastering the CJ2000 isn't just a matter of national pride anymore, it's a matter of survival for the entire wide-body ambition. If the engine program fails or falls badly behind schedule, the entire C929 dream collapses right along with it. But if they actually succeed, China stops being just another customer buying Western hardware and starts becoming something far more powerful, a kingmaker in the global aerospace industry. And they aren't only thinking about their own domestic airlines here. They're looking at the entire global stage, aiming to offer developing nations around the world a cheaper, far more accessible ticket into the modern jet age. It's very much a now or never mentality that has pushed the entire development timeline into overdrive, compressing what would traditionally take decades of careful research into what's effectively just a handful of years. It's an incredibly bold approach. It's genuinely risky, and it has left engineers and executives across the Western aerospace world more than a little uneasy. But successfully saving billions of dollars in engine spending is really only half the battle here. The much harder question is this: how exactly do you go about building something that can genuinely outperform a masterpiece of modern engineering like the Rolls-Royce Trent series? And if the raw performance numbers we've already covered didn't rattle the established players enough, what's been happening quietly behind the scenes in the supply chain absolutely will. For decades, there was one very specific component of a jet engine that industry experts consistently insisted China would never be able to master: the single crystal turbine blade. These aren't just simple pieces of shaped metal. They're arguably the crown jewels of modern metallurgy, some of the most technically demanding components manufactured anywhere in the world. Picture a small blade that has to spin at somewhere around 10,000 revolutions per minute while continuously enduring temperatures that actually exceed the melting point of the very metal it's made from. A feat only possible through incredibly precise internal cooling channels and an almost flawless atomic crystal structure. In the past, Chinese manufactured versions of these blades would frequently crack or fail under that kind of extreme stress, forcing Chinese manufacturers to rely heavily on imported blades from Western suppliers, or, for a period, from Russia. But here's the part that genuinely shocked a lot of industry observers. China has reportedly now achieved something close to full self-sufficiency in mass-producing these single crystal turbine blades domestically. By mastering both the internal cooling technology and the incredibly precise atomic structure these blades require, Chinese manufacturers have effectively eliminated what was long considered their single biggest technical vulnerability in the entire jet engine supply chain. For the engineers involved, it's described as a moment of enormous national pride, something close to a Sputnik moment for China's aerospace industry, one that reportedly left Western intelligence and industry analysts scrambling to figure out exactly how the technological gap closed so quickly. To put that achievement in perspective, it's worth remembering just how few countries on the planet can actually manufacture single crystal turbine blades at scale in the first place. For decades, this capability sat almost exclusively with a small handful of companies in the United States, Britain, and France, protected by layers of export controls, patents, and closely guarded manufacturing processes passed down through generations of metallurgists. The barrier to entry wasn't just financial, it was almost tribal, built on decades of accumulated trial and error that simply couldn't be shortcut by throwing money at the problem alone. The fact that Chinese state labs and manufacturers appear to have cracked the core of that process in a fraction of the time it took the original pioneers suggests either an extraordinary amount of independent research, a significant amount of reverse engineering from imported components, or more realistically, a combination of both working in parallel. Whatever the exact path, the outcome is the same. A critical choke point that Western nations relied on to keep newcomers out of the premium engine business has effectively been removed from the equation. It really is an extraordinary rate of progress when you step back and look at the timeline involved. But China isn't only winning ground on the factory floor and in the testing labs, they're simultaneously playing a very high-stakes game of diplomatic hardball on the regulatory side of this story. For a very long time, the West held what amounted to an ultimate kill switch over the entire global engine market: safety certification. If regulators at the FAA in the United States or EASA in Europe refused to sign off on a new engine, that engine simply wasn't going to fly internationally, full stop, no exceptions. However, China is now quietly building its own regulatory wall around this exact issue. The Civil Aviation Administration of China, known as the CAAC, is no longer content with simply following the rulebook that Western regulators wrote decades ago. They're actively building out their own certification framework. And here's the genuinely bold move buried inside that shift. China appears to be leveraging its own massive domestic aviation market, which happens to be the single largest in the world, to push for what amounts to a reciprocal recognition strategy. Essentially, the underlying message to the rest of the world is this: if you want your Boeing and Airbus aircraft to keep flying freely through Chinese airspace and serving Chinese airports, you're going to need to recognize the CJ2000 as a certified, safe engine in return. It's an extremely clever and, frankly, aggressive use of leverage. China is using its trillions of dollars in aviation purchasing power to effectively sidestep the kind of technical red tape that has historically kept outside newcomers locked out of the global engine market for good. In doing so, they've essentially neutralized the West's traditional ability to use safety certification as an informal trade barrier against emerging competitors. At this point, It's really no longer a question of whether the rest of the world eventually accepts Chinese-built jet engines. It increasingly looks like a question of exactly when that acceptance happens. Can you feel just how much the ground is shifting underneath this entire industry right now? The century-old monopoly is starting to crack, global supply chains are quietly reorganizing themselves, and real leverage in this industry is steadily moving eastward. What we're watching unfold here is nothing short of a total restructuring of how the global aviation sky actually works. But with all of these individual pieces finally starting to click into place, thrust, materials, business model, supply chain independence, and regulatory leverage, what does the actual future realistically look like? Both for the everyday traveler and for legacy giants like Rolls-Royce, who now find themselves constantly looking over their shoulder? There's also a talent dimension to this story that rarely gets the attention it deserves. Building an engine program like this one doesn't just require capital and factories. It requires tens of thousands of highly trained propulsion engineers, materials scientists, and precision manufacturing technicians, the kind of specialized workforce that usually takes generations to build organically. China has been aggressively expanding its aerospace engineering programs at universities across the country, recruiting talent that previously might have gone to work for airlines or general manufacturing sectors, and in some cases drawing back Chinese-born engineers who trained and worked at Western aerospace companies before returning home. That kind of deliberate talent concentration, backed by state funding and a clear national mandate, is exactly the sort of long-horizon investment that's easy to underestimate in the moment, but incredibly difficult for competitors to counter once it starts compounding over a decade or more. So where does all of this actually leave us? We're not simply looking at the emergence of a new jet engine on a spec sheet somewhere. We're witnessing something closer to the birth of an entirely new sky order. For roughly the last 50 years, the aviation industry operated as a fairly comfortable, Western-led duopoly, a closed club where the rules of the game were largely written and enforced out of London, Paris, and Washington. The CJ2000, whether or not it fully lives up to every projection being made about it today, functions as a genuine sledgehammer aimed squarely at that closed door. There's also the question of what this means for ticket prices further down the line, something that matters enormously to the millions of ordinary passengers who never think twice about which engine is bolted onto the aircraft they're boarding. Engine costs, both the upfront purchase price and the decades-long maintenance bill that follows, eventually get baked into airline operating costs, and operating costs eventually show up in the price of a ticket. If Chinese engines genuinely deliver on the fuel efficiency and reduced maintenance numbers being projected, and if that competitive pressure forces Western manufacturers to respond with better pricing and more flexible service terms of their own, the long-term winner in all of this could end up being the everyday traveler, who benefits from lower fares driven by a more competitive engine market, even if they never once think about where that competition actually came from. Picture a future, just a handful of years from now, where a growing regional airline in Southeast Asia, across Africa, or somewhere in South America is looking to expand its long-haul network. In the past, that airline effectively had no real choice. It had to pay what amounts to a Western premium, purchasing expensive engines, and then locking itself into even more expensive, exclusive lifetime service contracts on top of that. Now, for the first time in decades, that same airline has a legitimate, credible alternative on the table. A high-tech, genuinely fuel-efficient Chinese engine option that comes without the golden cage of an exclusive maintenance monopoly attached to it. This shift really isn't just about the underlying technology anymore. It's about something closer to the democratization of global air travel itself, about who ultimately gets to fly, how affordably, and on whose terms. There's also a ripple effect worth thinking about here that goes well beyond just China and the West. Countries that have historically had almost no leverage in aircraft procurement negotiations, smaller nations with limited fleets, and even more limited access to favorable financing could suddenly find themselves with genuine bargaining power for the first time. If a country's flag carrier can credibly threaten to walk toward a Chinese engine and airframe combination, Western manufacturers and lessors may find themselves forced to sweeten financing terms, extend more flexible maintenance packages, or lower prices simply to keep the customer in the fold. In economics, that's exactly what happens when a genuine second or third supplier enters a market that used to be tightly controlled by just one or two players. Prices soften, terms improve, and the customer, in this case the airline, ends up with meaningfully more negotiating power than they had before. It's a dynamic that could quietly reshape aircraft financing and leasing markets long before a majority of the world's fleets ever actually switch over to Chinese engines. Still, no success story like this one comes without its share of real difficulties and open questions hanging over it. Can China actually sustain the extraordinarily strict, unforgiving quality control standards required to safely support millions upon millions of cumulative flight hours over the coming decades? Will airlines, and just as importantly, everyday passengers around the world, genuinely come to trust an engine core built and certified in China when there are literally thousands of lives at stake, 35,000 feet above the ground, on every single flight? The emotional and human stakes involved here really couldn't be much higher. For the engineers working late nights in Shanghai, every single successful test result represents an emotional, hard-won victory after years of grinding incremental progress. For the executives sitting in boardrooms at Rolls-Royce, meanwhile, it's a cold, uncomfortable reminder that the comfortable era of unchallenged Western dominance in this industry may finally be coming to a close. At this point, the CJ2000 has become something much bigger than just a piece of rotating machinery bolted underneath an aircraft wing. It's become a symbol, a very visible representation of China's broader effort to unshackle itself from decades of dependence on Western aerospace technology. And while Rolls-Royce absolutely remains a genuine titan of the industry, with an unmatched legendary history stretching back over a century, the rapid rise of this Chinese competitor signals something that feels like a fundamentally new reality taking shape. The sky is no longer some kind of exclusive private playground, reserved only for Western manufacturers and their traditional customers. Whether this entire strategy eventually results in a full-scale global takeover of the engine market or ultimately becomes a very expensive, high-stakes lesson in overreaching ambition, one thing seems genuinely certain at this point. The global aviation world is not going back to the way things were before. The competitive landscape has already shifted, and every major player, from Toulouse to Seattle to Derby, is now recalculating their long-term strategy with this new reality firmly in mind. But remember, the engine itself is really only half of this larger story. To truly understand exactly why China feels so confident challenging the established heavyweights of this industry head-on, you really need to look at the equally rapid progress happening on the actual aircraft this engine is ultimately being built to power. The upgrades and developments happening on that side of the program are honestly hard to believe if you haven't been following along closely. Thanks so much for watching, and if you enjoyed this deep dive, make sure you're subscribed so you never miss the next one as we keep tracking exactly where this fast-moving aerospace story goes next. See you in the next episode.